Good morning. Thank you again for the opportunity to present today. I'm Camille. I'm the Director of Operations of SB Quantum. We are based in Sherbrooke, Quebec, in the heart of the Quantum Innovation Zone. And I'm here today with my colleague, Adrian. And as Mark said, we have a very nice demo here today with our device. So come and have a look later today. At SB Quantum, we are developing next generation magnetism, magnetometry based on NV centers in diamond. On the very left of this slide, you can see a diamond lattice. When a diamond is pure, it's going to be composed only of carbon atoms. But here we are very interested on one specific impurity in diamond that's called an NV center, which means having a nitrogen and a vacancy, neighboring vacancy, instead of having two neighboring carbon atoms. To measure the magnetic field, we shine a laser and microwaves to the diamond, and we retrieve the red light. And it is in this red light that we are able to retrieve the magnetic field measurements. So you can see on the right picture of the device, but it's always better in live. So you have it right here. And you can see a quick comparison of our technology versus different other techniques of magnetometry. But I want to point out the two main aspects. So first, our technology enables to do room temperature measurements, which is a very great advantage for integration. But also it is possible to measure not only the magnetic field intensity, but the magnetic field in value in each axis of space. At SB Quantum, we want to move beyond the magnetometer as a commodity game. So actually, we are not only developing the sensor itself, the magnetometer, but also ML compensation algorithms on the one side and data analysis and interpretation. So for compensation algorithms, they are essential to integrate the magnetometer into different platforms, as this platform will have a magnetic signature, and it's an issue, and it's considered as noise as we are measuring magnetic fields. So these algorithms enable to integrate our sensor into a satellite that will be launched into space next year in 2025, but also to integrate our sensor into a drone for different applications that I'm going to detail right after. Data analysis is also very important, as for the end user, the goal is to have they are not interested in having the raw data, but having like a full interpretation of like what it means for their specific use case and specific needs. So this technology has three main application domains. On one hand, mineral discovery, as so magnetometry has been used for decades for mineral discovery. So in order to detect mineral deposits on the field, thanks to a non-destructive technology, what we have developed at SB Quantum enables to have 9 times the magnetic maps compared to the classical solutions of the industry, making a difference for mining companies in the field. For navigation, so as I said, we will launch our technology into space next year, and that's part of a challenge called MagQuest, which goal is to refine the world magnetic model, which is actually the Earth magnetic field maps. So in this challenge, we were able to do extensive testing at NASA's facility in Washington. And finally, this technology is also can also be used to detect objects and to classify them. For example, for special forces, they are really interested to see when they enter a room, what is behind, if there are weapons, if they are moving. So this is something that's possible to see behind walls thanks to this technique. We are looking for different aspects of our technology. First, collaborators for R&D project to collaborate, but also, of course, pilot opportunities to go in the field and deploy our technology for all of the applications I've detailed earlier. And finally, of course, early adopters to test our technology. Thank you so much for listening, and thank you again, Mark.